Hello and welcome. Today we're going to be doing lesson 1-6, page 40 in your books. We're going to be tackling relations today. Hopefully we'll get through this quickly. Only got 5 slides to go through. So let's get started. Alright, first word we're going to be working with today. We're going to be doing the coordinate system, which is an intersection of horizontal and vertical number lines. You'll see that I have a horizontal number line running across here with 1, 2, 3, 4, 5, 6 positive numbers on the right and -1, -2, -3, -4, -5, -6 on the left side. And then going up and down, I also have a vertical number line going 1, 2, 3, 4, 5, 6 on the top and -1, 2, 3, 4, 5, 6 down the bottom. These have special names. All right. The horizontal one, the bold line, we call that the x-axis. And the vertical one, we call the y-axis. You'll see all the blue ones, those are also numbered lines, and when you put them together and they intersect, we call that the coordinate plane. All right, the point in the middle here, 0, 0, where the two intersect, we don't go any to the left or to the right. We don't go any up or down. We call that the origin. Point 0, 0 is the origin. All right. The other term that we need to know is ordered pairs. And ordered pairs are written with parentheses, with the x-coordinate being the first one, and then the y-coordinate being the second one. So you can see that the ordered pair 0, 0 means we go 0 to the right or to the left and 0 up or down for my y-coordinate, and that gives us the origin. All right? All right, moving on, we have another term that we need to know, and that is a relation. And a set of ordered pairs is called a relation. So this right here is a relation. And in your homework, it will say represent this relation in 3 different ways. And the 3 different ways that you're going to represent these are number 1, a mapping, 2, a table, and 3, graphing. So the first one is a mapping, and I'll bring it over here if I can. Here is a mapping. You have in one column all your x values. Okay, so if you look at the relation, we had our x values of -2. Remember, it's the first one in our ordered pair. -1, 0, 1, and 2 are all of our x values. Okay, so we put them in a column, in a chart. And x is also known as a domain. So I know I'm throwing a lot at you, but x is also known as a domain. So when somebody asks, what is your domain? All they're asking you is, what are your x values? All right. Then we look at our y values, and I have 4, another 4, so I've put 4 here just one time. 6, put it here. 8, and 2/8, so I put that here. So you have a column for your x, your domain, and you have a column for your y, which is your range. So if somebody asks what's your range, they're talking about your y values. And then what I've done is I've drawn a line from your domain to your range in what they match. So here we have a -2, 4. So I've taken my domain, -2, and I've paired it with the range of 4. I had a -1 and a 4. So from my domain, I've drawn a line from -1 to 4. In my domain, I've had a 0. So I've drawn 0 is matched up with 6, as it is in this pair. And 1 and 2 are both paired to the range of 8. So from 1 and 2, I have a line going to 8. That's one way. Another way to do it is by a table. And a table is just that. You have a column for your x's, you have a column for your y's, and then you just make a table. So -2, 4, -1, 4, x, 0, 6, you'll see it here, 1, 8 is right here, and 2, 8. And the very last way to represent this is by doing a graph. All right? So we need to graph these points. To graph them, we just start at the origin, and we're going to follow our coordinates. So our x-coordinate for the first one, let's do this one first in red. We start at the origin, we go 2 spots to the left, -2, and then our y-coordinate says to go up 4, so -2, 1, 2, 3, 4. And this would be that point right where they intersect, and it's really hard to draw circles there, so sorry, that would be should be a better circle. Our next one is -1, 4. So starting at our origin, we go to the left, -1, and then we go up 4. 1, 2, 3, 4. And that's where we should draw our second point. Yeah, right there. All right, for our third one, 0, 6. That purple's hard to see, I get that. We go left or right, 0, so we're going to stay right here on the y-axis, and we're going to go up 6. 1, 2, 3, 4, 5, 6. And so our purple point, should go right there. All right, let's try 1, 8. 1, 8 will be in green. It says we go right 1 place, and we go up 8. 1, 2, 3, 4, 5, 6. I ran out of room. I don't have the room, so it would be up here somewhere, 1, 8. Imagining that the graph extended to 7 and 8. And then the very last one, we have 2, 8. And I'll underline that one, I guess, in black. Why not? Okay, so to graph this one, we would start at the origin again. Our coordinate says to go to the right, a +2, so 1, 2, and again up 8. I should have made a bigger graph, I guess. And you go up 8, and it would be somewhere up there. And now I have represented this relation in 3 different ways. This one, same deal. They want you to express this relation in 3 different ways. You can try this by yourself, pause the video, see what you can come up with. Alright, I don't have these prepared out like I did on the last slide, so I'm going to do my best to write it. Express this relation in 3 different ways. So I need to make a list of my x values, or my domain. I'm going to do the mapping first. So in my x, I have, I'm going to go numerical order, -2. I have a 0. I have a 2. And a 4. In my y values are, I have one -1, a -4, and I should have went in order, and a 3. All right, and when I'm mapping, I need to connect them. So let's see, a -2 connects with the -1. The 4 the 0, connects with the -4. The 2 connects with the -4 as well, so they both go to the -4. And the 4 connects with the 3. And now I've mapped that out. Alright, for the table, you're going to need to do the exact same thing. You're going to make a chart for your x values or your domain, and I have a -2, 0, 2, and 4. And then I need a column for my y values or my range, and this should be a table. And I apologize, the software doesn't have a really super duper way for making a table. But here's my table. -2 is paired up with a -1 for the y. 0 is paired up with a -4 for the y. My x value of 2 also has a -4. And my x value of 4 has a y value of 3. So that would be my table. To graph these, I start at my origin, and I go for the first coordinate, 4, 3. I go over 4 places, and I go up 3, so it would be right here. For my second coordinate, I do -2, -1, so to the left 2 places, and then down 1 place, should be right there. For my third coordinate, I have 2, -4 to the right 2 places, and then down 4, 1, 2, 3, 4, should be right there, I believe. And 0, -4, tells me to go left or right 0 places, and then down 4, so it should be right there. Now I've represented this relation in 3 different ways. Last thing that we need to talk about is the independent variable and the dependent variable. And math vocab gets lost in a bunch of jargon, and it's hard to understand until we go through an example, and I'll do my best to explain it. But the independent variable determines the output, and the dependent variable, check this out, depends on the independent variable. Let's look at our example right here about the dance committee. The dance committee is selling tickets to the fall ball. The more tickets that they sell, the more money that they can spend for decorations, which makes sense because they'll get money from selling the tickets. Okay? What's not affected by any factor is the independent variable. So our independent variable in this problem is the tickets that they sell. Okay? What is dependent on the amount of tickets that they sell is the money that they can spend for decorations. If they sell a lot of tickets, then they can spend a lot of money on decorations for their ball. If they don't spend a lot of tickets, well, they don't have a lot of money to spend for decorations. So that we would call is our dependent variable. Check out the on your own, and as I read it, see if you can identify which one is dependent and which one is independent. In warm climates, the average amount of electricity used rises as the daily average temperature rises. As the daily average temperature decreases, so does electricity usage. So which one of these is affecting the other one? When we look at it, we think about it, we have either the electricity usage is affecting the temperature, or the temperature is affecting the electricity usage. Well, we look at it and we see in warm climates the average amount of electricity used rises as the daily average temperature rises. So as it gets hotter, people are probably using their air conditioning. So our independent variable, the one that's not affected by the other, is the temperature. Okay? And the one that is dependent on whether or not it's hot outside is the electricity usage. That's all we had to cover today. These videos always turn out to be longer than I anticipated at the beginning, but hopefully they are a help to you, and you'll come back and you'll keep watching them. Thanks.